Okay, before we answer the questions or problems, let us do a quick review on continuity. It's a calculus course, but continuity or discontinuity is like in real life. If something is not continuous, and there must be a break somewhere. Okay, and in this lesson, it's about looking at the graphs. Okay, if a graph is drawn in this manner, there's no hole, there is no asymptote, okay, there's no gap, then the graph is, or the function is continuous, literally. Diba? That's how we understand the continuity. But sometimes there are graphs in which, say, on this side, it will be cut, and then it will continue on a different number, and let's say instead of a curve, it will go as a straight line. So that obviously is discontinuous. Okay. There are two types of discontinuity. One that we call removable and essential. So essential and removable. Okay. The removable discontinuity is like there's a graph, there's a hole, and it will continue from that hole. Okay. It was called removable because you can actually introduce a number, a value that will fill the hole so that it becomes somehow continuous. That is why you can remove the discontinuity. So removable discontinuity. But for essential, as we have seen in the previous illustration, if the graph is in this manner, then you cannot do something to complete the graph because there's an obvious gap from one point to another. So it's essential. So that's another case. Now, another type of essential is when you have an asymptote. So on that asymptote, the graph will say go to infinity on one side and then say negative infinity on the other side. So there's still a gap. You cannot remove the discontinuity there. So it's an essential discontinuity. Okay. Now, these gaps or discontinuities are connected to the limits. Okay. If we look at, so let's number our cases. Case number 1, case number 2, and case number 3. Only number 3 will show that the limit exists. Okay, but because when we say the limit exists, when you go from the left and when you go from the right, even if the value is not existing, the limit will still exist. Okay, do not be confused with the function value and the limit value. The limit can exist even if the value on the function is not existing. Okay, so they're going to the same point, supposedly. So the limit exists on number 3. Okay, but in number 1, from the left, there is this number. From the right, there is this number. They're not the same. If the limit on one side, on both sides are not the same, the limit will not exist. Okay? In number 2, it's the same case. So going to positive infinity from the left and going to negative infinity from the right. Even if I change that to going to positive infinity, still, you don't say they have the same limits because the limit does not exist when we say infinity. Okay? So, gap pa rin, essential discontinuity. So, to summarize the points, the 1 and 2 cases, the limit does not exist. Okay? But for number 3, the limit exists. And we will utilize that idea when we do the 3 steps in determining whether a function is continuous or discontinuous. Okay? So those are the things that we need to know. Now we go to the specific procedure on how to identify whether the limit is whether the function is continuous or not. Example 1 is f of x is equal to 4x squared plus 3x minus 2, and we want to identify whether it's continuous on x equals 2. Okay? In general, to find or to determine whether the function is continuous at a specific number, we do the 3 steps. We check if f of a is the value of x we're trying to check. If f of a exists. Number 2, we check if the limit as x approaches that number of the function exists. And then number 3, we have to check if the two will exist, are they the same? Okay, so note that the moment number 1 will fail, then we can already say the function is not continuous. The part 2 will fail, it's discontinuous. We don't even need to check part 3 anymore. We only do number 3. If f of a exists, limit will exist, then we check if they are the same. And number 3 can also fail. It's possible that they're not the same. Okay, so our first example is f of x equals 4x squared plus 3x minus 2. Let us do step number 1. F of a. What is f of a? F of 2. Because we're checking if it is continuous at 2. Our a is 2. So f of 2 is 4 times 2 squared. So that's 16 plus 6 minus 2 equals 20. So the value exists. Then we proceed to number 2, if the limit will exist. The limit as x approaches 2 of the function, and the basic technique when we do the limits, substitute. So we will get the same number because we are substituting the same number. So part 3, are they the same? Yes. So it is continuous at x equals 2. Okay? Let us understand it further. Because we don't want to be contained on the steps. But if you think of f of x as 4x squared plus 3x minus 2, what kind of graph can we achieve if we graph 4x squared plus 3x minus 2? Parabola. Wala namang gap sa parabola. So even without checking, well, you only do this if the problem says perform the 3 steps to verify. But in your mind, you already know it is continuous. You're just showing a proof. Okay, because it will never be discontinuous at any number. Parabola is from negative infinity to positive infinity in terms of domain. Walang gap. Okay, so it's continuous. Okay, and then let's go to B, so that we could see how to apply when one of the conditions will fail. So we have to check at x equals 3. Step number 1, f of 3. 4 times 3 over 3 minus 3 is 12 over 0. Undefined. The value does not exist. Okay, actually x equals 3 was chosen because we can see in the denominator that it will be undefined, even just by looking at the denominator. Okay, so the first one failed. You immediately say it is already discontinuous. Okay, but what is the use of part 2 and part 3? There's always a follow-up question. Well, in most cases, that the moment it is discontinuous, you have to classify it as first, essential, or removable. And then if it's essential, you determine if it's infinite, and the other one is the jump with the gap. That's the jump discontinuity. You will know that the moment you evaluate the limit at the number. So you have 4x over x minus 3. Well, substitution will lead you to 12 over 0 and it's undefined. And in limits, when it's undefined, it's infinity. Tama? Hindi naman siya 0. But what is it? Is it a positive or negative infinity? Not immediately. Because to check the limit, we have to identify the limit from one side, from the left, and then we check the limit as x approaches that number from the right. So 4x over x minus 3. 4x, same, x minus 3. But how are we going to deal with each limit? Remember the one-sided limit example? You select a number from the left of 3. You can just get the number before it, so which is 2. So the 0 is coming from what number? If you place a number smaller than 3 on x, 2 minus 3 will become negative 1. So the 0 is, say, that's still at 12. The 0 is coming from a negative or negative numbers. So infinity but negative infinity. Did you understand? And on the other limit, if we do the same thing, you will expect this to be positive infinity. Okay, so what is happening in the graph? Okay, because the possible discontinuity is at 3. At 3, there is actually a vertical asymptote. That from the left, we don't need to know the exact graph. From the left, we know that it's going to negative infinity, and from the right is going to positive infinity. Okay, it could be above the x-axis, it could be below the x-axis. But what we know is that from the left it's going to negative infinity, and from the right it's positive infinity. And choosing between jump or infinite, it's very obvious that it's an infinite discontinuity. Okay, to name the type of discontinuity. Okay, so we'll cut it there. We'll take a short break. When we go back, we'll do letter C. Okay.